Now in this video we're going to continue to talk about angles, but instead of using degrees we're going to use another unit of measure which is referred to as our radian. So here we want to talk about radians, and this is going to be a very important topic, so you really need to make sure that you understand this before we continue on through the course, because this is going to be very important for the remainder of this class. So where before, if we thought about a circle and we went all the way around the circle, starting with 0 degrees, and we would put 0 with our little degree symbol, but now when we're talking about radians, we're just going to put a 0. And for the radians, there's really no units there, so it's just going to be 0 to represent 0 radians. And if we were to go all the way around the circle to here, instead of 360 degrees, this is going to be equal to 2 pi. Okay, so in terms of radians, the 2 pi is going to give us basically one trip around the circle. So now, if we thought about taking this circle and if we cut it in half, instead of going all the way around, if we only went halfway around, then we could think of this as 2 pi, and we could certainly just cut that in half. So half of 2 pi, so if we take 2 pi divided by 2, the 2's are going to cancel, and we're left with pi. So halfway around the circle would be pi radians. Okay, so that's the representation for half of the circle, would be 1 pi. All right, now I want to think of this more in terms of fractions for just a minute. And we're still going to look at using our circle here. And we just stated that if we go from 0 to pi, we're looking at half of the circle. So for right now, we want to basically ignore this bottom part, okay? And if I said I want to take the top part of the circle and we want to cut that in half, well, I'm sure you would say, well, we would draw a line through here. If we cut that top part of the circle in half, that would be half of it. So that means that if all the way around or halfway around this top part we have pi, so I think it would make sense then we would take half of that, which would be pi over 2. So that gives us pi over 2 for the measure for that angle. And remember, we said, just as a reference, this is the same thing as our 90-degree angle. Okay, so if that's pi over 2, so if we think of starting from 0, this would be pi over 2. And if we add another pi over 2, that would equal to pi. Because if we take pi over 2 plus pi over 2, we would get 1 pi over 2 plus 1 pi over 2, which would be 2 pi over 2, which is equal to 1 pi. So then if we add another pi over 2, that would bring us down here. So if we take pi plus pi over 2, then we need a common denominator of 2. So that would give us a 2 on the bottom. So we would get 2 pi plus pi over 2, which is 3 pi over 2. So that means the angle down here is 3 pi over 2. And again, we could think of that as 1 pi. If we go all the way around here, that's 1 pi and then another 1/2. So that's 1½ pi. Well, 3 pi over 2 is 1½ Now, typically, in terms of radians, we're not going to say 1½ pi. We're typically going to say that's 3 pi over 2. And again, we can think of that as 1½ pi. So we can think again, if we add another pi over 2, or if we add another, thinking of this as, if you want to think of it in terms of just fractions, we're adding another pi over 2 here, and we can think of that as kind of adding another 1/2. So if we take 3 pi over 2 and we add another pi over 2, 3 pi plus 1 pi, we already have a common denominator. That's going to be equal to 4 pi over 2, and that's going to be 4 pi over 2 divided by 4 divided by 2, which is simply 2 pi. And that's what we said over here before. All the way around the circle is going to be equal to 2 pi. Okay, so I know that a lot of you don't like fractions, but I will tell you now that you need to think of this in terms of fractions, and it's really not that difficult for the fractions we're going to be looking at. So be very careful and make sure you understand the idea of how we're getting from 0 to pi over 2. If you add another pi over 2, pi over 2 and pi over 2 gives you pi, and another half is 3 pi over 2, and all the way around. Okay? All right, if we take our same circle, and now, once again, I want to focus on really starting off, we know the top part is 0 to pi. So the top part here again, for starting out, we want to ignore this bottom. And now I want to divide the top part into 4 equal pieces. Well, just imagine if you were cutting up a slice, or imagine if you were had a pizza and you want to cut half of the pizza. If you cut half of the pizza, it's already gone. So we're going to pretend that we have a pizza. We've already eaten this half of it. So all we have left is the top here. And we want to come up with 4 equal slices. So we need to cut this into 4 equal pieces. Well, we could easily do that by taking half like we did before. And we said that would be pi over 2. But then we need to take half of each one of these, and now we have 4 equal pieces. So basically we have 1/4, 2/4, 3/4, and 4/4. So 1/4, 2/4, 3/4, 4/4, which is 1 whole. So that's 1 pi. So that means this piece would be pi over 4. Okay, again, think of this as we're taking 1/4 of pi. Well, remember, pi is halfway around here, so this is pi over 4. If we add another pi over 4, we would end up with 2 pi over 4. Okay, now 2 pi over 4, that reduces to pi over 2. And then if we add another pi over 4, well, 2 pi over 4 would be 3 pi over 4. And then if we add another one, we would end up with 4 pi over 4. And again, the 4's cancel, and you're left with 1 pi. So again, that gives us our measurements for the top part of the circle. And of course, then we could continue here to the bottom. And if we do that, again, we would cut that in half. And we add another pi over 4. Well, 4 pi over 4, another pi over 4 would be 5 pi over 4. And then another one would be 6 pi over 4. And again, the 6 pi over 4, that would be equal to, if you reduce this to lowest terms, that would be 3 pi over 2. We would add another pi over 4, which would be 7 pi over 4. And if we add another one, we would get 8 pi over 4. And again, that divides out to 2 pi. Okay, so when you write your radians, you always want to write this fraction in lowest terms. So you don't really want to say 8 pi over 4 when we could simplify that to 2 pi. Now, the angle that I'm going over right now are some of the special angles that we're really going to be working with. So again, you should start out trying to memorize the location of these radians. 0 to pi, you could start there, and then realize that if you cut that in half, you get pi over 2, and then you could go around to 3 pi over 2, 2 pi, and then you want to start to memorize the next one, which is 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and then you can just keep adding the pi over 4 until you get to 2 pi. All right, the next circle we're going to take, and now instead of dividing it into 4 equal pieces, we're going to divide it into 6 equal pieces. So again, we could think of this as we're starting going from 0 to pi. Once again, ignore this part of the circle for now. And if we want to cut this into 3 equal pieces, and we can kind of estimate this, again, we're going to cut probably here and here. So now if you think of it in terms of fractions, we would have 1/3, another third. So here we would have 2/3, and 3/3. Okay, but instead of thinking of this in just in terms of the fraction, we want to use our symbol pi. So 1/3, we could think of this as, you could think of it as 1/3 pi, and the way we're typically going to write that is pi over 3. So that means 1/3 pi, which is really pi over 3. And if we add another pi over 3 to this, we would get 2 pi over 3. And then we could add another 1/3, and that would give us 3 pi over 3. And we could continue this same pattern all the way to the bottom. And then you would get 4 pi over 3, 5 pi over 3, and 6 pi over 3, which again is equal to 2 pi. All right, so now we show that we can divide this top part of the circle. Now be careful, we're not dividing the whole circle into 3 equal pieces. When we're doing this, like we did before, we're looking at the top part, dividing that into 3 equal pieces. So that means the whole circle now is divided into 6 equal pieces. So when you think of the fractions, remember we're dividing only the top part of the circle into thirds, 1/3, 2/3. So again, as you go around, you have your 1/3, 2/3, 3/3, which would give you 1 whole. And then that pattern continues to the bottom. And again, that's the same thing that we had up here. You have your 1/4, 2/4, 3/4, and 4/4. All right, now we're going to take our circle and we want to divide the circle into, or the top part of the circle rather, we want to go again, we're thinking from 0 to pi. We'll ignore this part for now. And from 0 to pi, we want to divide this into 6 equal pieces. So we could easily do that and say, well, if we take half here, okay, and then we need to have 6, so that means we need 3 equal pieces then on this section here, and we need 3 pieces over here. And so we could do that by kind of guessing here and here. We'll pretend those 3 are equal. And over here we would divide. And now we have 1, 2, 3, 4, 5, 6 equal pieces. So therefore we would have 1/6 pi, or simply pi over 6. And I'm going to keep adding pi over 6 each time. So then we would have 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then we would eventually get to 6 pi over 6. And we of course would go back and simplify these. 2 pi over 6 here, notice what happens. Well, pi over 6 we can't reduce any further, but 2 pi over 6 will go to pi over 3. And if you'll notice then 3 pi over 6, this would simplify to pi over 2. And then once again here, 4 pi over 6, that would go to 2 pi over 3. And then over here again, 6 pi over 6 is equal to 1 pi. So if you notice here, dividing this into 6 equal pieces, notice what happened. We get our pi over 3. And then of course, we would have 2 pi over 3. And then over here, this we could think of then as 3 pi over 3. So if you notice there, we still have our circle dividing into 3 equal pieces like we did up here. So where we had the pi over 3, 2 pi over 3, 3 pi over 3, because that's going to be here, this multiple of 6, we're still going to get, if we reduce the 2 pi over 6 and 4 pi over 6, we're going to get pi over 3, 2 pi over 3. So here you can kind of see a little bit of relationship between dividing this into 6 equal pieces as opposed to when we divide this into the 3 equal pieces here as we go 1/3, 2/3, and 3/3. And then, of course, we can continue this pattern down below. If we go bigger than pi, we would just certainly think about extending each one of these. So then down here, let me try to get these out of the way. So down here then, if you had we'll continue with the 6 pi over 6, so we have our common denominator. Well, then we would have 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6. And once again, we could reduce the fractions. 8 pi over 6 here, that's going to reduce to 4 pi over 3. The 10 pi over 6 here was going to reduce to 5 pi over 3. And then, of course, the 9 pi over 6 would be 3 pi over 2. And 12 pi over 6 would be equal to 2 pi. So hopefully you're starting to get the hang of this as far as how we can calculate our radian measures. And keep in mind, 0 to pi is half of the circle, and then all the way around we would be 2 pi. So now let me go back and substitute in some of the degrees for some of these radians. Just like we said before, this 0 is representing the radians, which would be equal to 0 degrees. And keep in mind, how do we know if we're talking about degrees or radians? Well, anytime we're talking about degrees, you're always going to have your little degree symbol, whereas with radians, you're not going to have it. So that's why here at pi, we could write this as 180 degrees. And just like over here, if we had our pi over 2, we have, again, 0 degrees, 90 degrees. This would be 180 degrees. And down here at 3 pi over 2, this is the same as 270 degrees. And then 2 pi would be the same as 360 degrees. And we could do the same thing for each one of these. The other ones that you want to be familiar with here, pi over 4 is the same thing as 45 degrees. And again, we have 90 degrees. And remember, we took 90 and 45, so here you get 3 pi over 4. So that's going to be the same thing as 135 degrees. And again, pi here, this would be equal to 180 degrees. And then 5 pi over 6, that would be 225 degrees. And then here at the bottom would be 270. And then again at 7 pi over 4, this would be 315 degrees. So hopefully you can kind of see the connection here. And you may be thinking at this point, why do we need to use radians? Well, we'll soon find out, because there's some formulas that we use where the degrees is not going to work. We have to use our angle in terms of radians. So once again here, the pi over 3, the connection you want to make here, this is the same thing as 60 degrees. So that means 2 pi over 3 then would have to be 120 degrees. And that means over here we would have 180 degrees. And you could continue around the rest of the circle. So 4 pi over 3, this would be 240 degrees. 5 pi over 3 is equal to 300 degrees. And then once again back to 360. So then even if we went to pi over 6, then pi over 6, the connection we want to make here is pi over 6 is actually equal to 30 degrees. Okay, so then that means that here at pi over 3, this would be 60 degrees. And then here we would have 90 degrees. 4 pi over 6, which is 2 pi over 3, so that would be 120 degrees. 5 pi over 6, then that would be equal to 150 degrees, and then we would come over here to 180. So again, you need to really make sure that you take time to study each one of these and realize uh, how we are calculating the radians. So, and it really, these are kind of the special angles. The most common that we'll be using are these ones that are dealing with the pi over 4, pi over 2, pi over 6, pi over 3. But realize those aren't all the angles. I mean, we could certainly use any fraction that we want. So, for example, if I was said we want to divide this into, let's say, uh, 12 equal pieces, then if we went from 0 to pi, then that means if we divide this into 12, we need to have, if I can do this here, we need 6 equal pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So then each one of these, you would have pi over 12. You could count this as 2 pi over 12, and you could keep going around till we get over here to 12 pi over 12. So any angle, any fraction that we want to divide this into, you're just simply dividing the circle, and particularly here again we're looking at just the top part of the circle. We want to divide that into whatever fraction we want. So we could divide it into 12 equal pieces, and that means each one would represent here pi over 12, or we could divide it into 24 equal pieces, so then each piece would represent pi over 24. Now, the common ones that you should memorize, and this is something you want to start doing, are the ones that are listed in your book. There should be a circle listed, and I'll have this scanned in as well for you. And this here is this particular circle where the ones I've gone through with the pi over 4, the pi over 3, pi over 6, and so forth here, that you want to make sure that you start to memorize and become very familiar with the location of each of these angles. So I realize at this point that I've probably rambled on long enough about this, but I really want to stress the importance that you understand kind of the location of these angles and how we're using the fractions here to divide up pi to indicate the location of these angles on this circle. And really, the better that you understand this, this is really going to make the rest of this course that much easier. So make sure you spend a little bit of time in understanding the location of these angles and the idea of radians, because this is going to be very, very important throughout the rest of this course.